And at the end, we can take further questions. And I say further questions because if you think of any questions as we go through the presentation, as Dan says, please enter them into the chat box and we'll pick them up as and when is appropriate. If we can move on to the next slide, please, Dan. You're probably all well aware that the Open Networks project is a major project for the electricity supply industry. It's helping the country deliver net zero carbon. And as I say, the electricity industry has got a very large part to play in this by delivering a smart, flexible energy system. Workstream 1, if we take 1A and 1B together, are looking at the processes and the data that is required to deliver this smart, flexible network. Workstream 1A really is looking at more the commercial side of flexibility. We're here today to talk about 1B, and 1B is really about the technical elements that network companies need to develop in order to deliver this smart system and a whole system. It's not distribution and transmission separately, it's the whole system development. So that is the objective of Workstream 1B, to put in place processes and data exchange between network companies, and primarily between transmission and distribution, but also between distribution companies themselves and IDNOs and distribution companies. So, as I say, there are 5 sub-products for there, as we see, and that's the way we're going to run through them this morning. As I say, the focus is on transmission to distribution processes, but others as well to support that. So we'll move on to the, I'll hand over now to John and move on to the next slide, where John's going to start to talk through products 2 and 5.
Okay, good morning, everybody. It's John West here. I'm have been for a few years now supporting the Open Networks project. This year, I'm sort of quite steeped in sort of Workstream 1B, and also do a bit of work on Workstream 2, which is more about connection processes and customer information. But less about me, more about Workstream 1B. We thought we would start with products 2 and product 5. Product 2 picks up the future energy scenarios, and product 5 is about how we go about identifying, our network companies go about identifying capacity limitations. So these 2 products are quite closely linked, and we think it's probably good to think about them both together, so that we can be sort of quite clear about where one product sort of starts and the other and ends, and where the other product begins. So the little diagram on the slide at the moment just sort of illustrates at a high level what product 2 and product 5 are. So product 2 on the left hand side, it's about future energy scenarios. It considers what those scenarios should be. You know, typically the scenarios that are developed for the National Grid published FES, you know, things like steady progression. It then goes on to think about, well, within those scenarios, what should be the specific forecasts of various elements, like low carbon technologies or distributed generation, different types of. And then the other part of the scenario, the FES part of it is to take those forecasts of the different elements and turn them into an electricity forecast, which means thinking about, well, okay, at what times or those particular elements likely to be active, and how much energy are they likely to require, how much electricity are they likely to require. So that's what's in product 2. In product 5, then we take those forecasts, those scenarios, and start to sort of apply them to the actual physical networks, and start to work out where there may be limitations or constraints going forward. So the 2 blocks on the right-hand side, there's evaluate network capacity and constraints, and then what product 5 is also trying to do, as well as working out or agreeing ways of identifying those constraints, is putting in place the reporting that network companies will use going forward to publish where those constraints are and what those limitations are. So that's a sort of introduction to product 2 and product 5. We've now got a few slides which will go into that in a bit more detail. I can see we've got one question that's come up from Graham in respect of whole system. So Graham is asking, please reassure me that this is right from the generator terminals to the end user, hence generator losses, outages are a relevant consideration. I think that's a good definition of whole system. I think what we're doing in Workstream 1B is much more focused on the networks part of that, and particularly the distribution to transmission interfaces, and trying to make sure that the data exchange elements, the processes there, are effective for that part of the whole system operation. So I think I agree, Rem, with your definition of whole system, but I think Workstream 1B is more focused into the TD elements of that. So could we go to the next slide, please, Dan? Okay. So the next slide just picks up a little bit on whole system future energy scenarios. So this is an area that is starting to mature, I think. I mean, obviously, the National Grid ESO has been publishing future energy scenarios for many years now, and it's got a very mature sort of annual process, which is well established and full of stakeholder engagement. Over the last probably 2 to 3 years, distribution companies have started to publish future energy scenarios as well, and you can see some pictures there which illustrate recent ones. So we've got a sort of process which is starting to mature around the production of future energy scenario documents. What we have in this particular product is really trying to build in that, and probably in 2020 the big areas of focus have been across the distribution future energy scenarios, and trying to work out how we get greater consistency of approach really across those scenarios, and we'll come a bit more to that on the next slide. But also the second part is sort of working out how those distribution energy scenarios are produced alongside the DFES scenarios, and making sure that there's good consistency there. There's good exchange of information, so that the the distribution scenarios can learn from the FES scenario, the GB FES scenarios, and vice versa. And there becomes a good sort of flow of information really between distribution companies and the National Grid ESO to make all of that happen well. So it's those two things that we've been really focusing on this year, which are down there really as elements 1 and elements 2. Developing the more consistent DFESs and improving data exchange so that we get better FES and DFES. I should say I use the term sort of building blocks there, and building blocks are really just the different elements of the forecast. It's a sort of language that we've started to use. So it might be a type of generator or an amount of EV charging or some other fundamental component which goes to make up the electricity forecast, and it just gives us a language or a set of things that we can use and start to compare across scenarios in an easier way. The third element there is just one that we have on our radar. We're always conscious of the fact that we may need to put in place some code obligations or some license changes to try and make these things more permanent going forward. As yet, in this sort of area, we haven't seen a need to do this, but we've got our sort of mind open to that. So if we could move to the next slide, please, Dan. So this slide just picks up on the distribution FES standardization. And what you can see there is a set of blocks on the left-hand side. I should say on this product, whole system FES, as with all of the other products in Workstream 1B, there is, each of the products has a team which is sort of sourced from the network company. So in this particular case, it will have representatives from each of the DNOs, also from the TO companies and from the National Grid ESO. And each team has got a product lead. So in the case of product 2, it's a guy called Hadi Kuzani who works with SSEN. And Hadi and the team have approached product 2 by sort of this part of it by breaking the task into those sort of 5 blocks on the left-hand side. So what they've done really to date, they've made pretty good progress really with DFES standardization. So they've got a high-level framework agreed, which is essentially how the scenarios are used, how regional aspects are built in, how the forecasts are done, and right through to publication. They've got a process agreed for DFES standardization, which is to some extent about how the DFES sort of interacts with the GB FES and how sort of feedback between the two work. The third block there, they've identified the elements that are subject to standardization, which is important in terms of getting consistency between the DFESs and to some extent with the GB FES. And the fourth block there then is they've agreed a timeline and process for how the DFESs and FESs sort of interact. And you can see the timeline along the bottom. You know, we've got essentially, if you go to the middle, you'll see the GB FES is published about July of each year, and the plan will be going forward that distribution FES is published around about sort of November, December of each year. So there'll be a sort of 5 or 6 month gap between the two. And this will allow a bit of feedback, I guess, really, or learning to come from the GB FES into the DFESs, and then from the DFESs after they're published into the GB FES. And you can see to support that process, there's a couple of touch points which have been agreed around about sort of December and February time, where there will be quite a high level of sort of interaction between the ESO and the DNOs to make sure that the right sort of things are being projected into the GB FES and DFES going forward to make it work. So there's a timeline that has been agreed and to which the network companies will work to going forward. And then the final bit of the final of the 5 blocks is just thinking about well, okay, if we do start to see differences between, let's say, a regional forecast of something and how that forecast is working in the national GB FES scenarios, then we've got a bit of a process developed as to how that gets narrowed down, how the network companies understand that, and start to make decisions about whether particular models or sub-models that might have in the FES processes need to be updated or changed or made more consistent. So there's a process which tries to keep the GB FES and the DFES reasonably consistent, and tries to make sure that the elements that make up those things get adjusted if they need to be adjusted. So that's product 2, DFES. I wasn't going to say anything further on product 2, but move on to product 5 now. So if anyone does have any questions on product 2, just pop them up. So product 5 then sort of moves on to the right-hand side of that earlier slide, and thinks about, well, how do capacity shortfalls get identified by network companies and reported. So this is quite a wordy slide. I should say this particular product is led by Jill Williamson, who works with Electricity Northwest Limited. And again, Jill has a product team that is working on this. So the 3 objectives that Jill and the team have identified is to, first of all, to identify a more consistent or common system of evaluating network capacity, which is objective A. And then objective B is sort of putting in place a standard report for how capacity shortfalls or limitations are made known. And objective C then is once A and B have been done, putting in place some monitoring, really, to understand how that's being done and make sure it's being done in a consistent way, and obviously learning from it. So the just below that little objective A, B, C block, there's a little bit on the what Jill and the team did in the early part of the year, which was to prepare a report on what network operators are currently doing in the reporting that they do for network capacity. And a report was published onto the Open Networks Workstream 1B sort of web pages back in May. which goes into some detail on the existing capacity reports that are published by network companies, mainly DNOs. And I think it showed that there's a lot of different reports, but there is a fair degree of consistency already in place, particularly where reports are mandated. And it also, I think, was helpful in it showed that you could start to characterize reports in different ways, i.e. sort of what parts of the network they cover, what dates they cover, what scenarios they use, that sort of thing. And by and large, all of these reports, there's good reasons for having them. They've been developed to do particular things. So that report published in May provides a bit of a base for Jill and the team to work on. So I think we've got another slide on product 5, but I think we've got a couple of comments or questions that have come in, which I'll just pick up on. And Dan will keep me right if I missed any of these, hopefully. So Graham again, DFES first. What aided your decision to make this top-down DFES into DFES rather than the other way around? Okay, great point. And apologies if it sounded like it was top-down. I think as you might imagine, there was a lot of discussion about this, whether it was top-down or bottom-up. And I think we probably ended up in a place where it's a bit of both, really. It's meant to be top-down in the sense of recognizing that perhaps having the 4 scenarios which are being developed for DFES is quite a good thing to have in the DFES situation as well, so that you can start to make some direct comparisons. But bottom up in recognizing that some of the interfacing really between distribution companies and let's say local authorities, as an example, will probably get much closer to the reality of what's happening in regionally, and therefore it's good to allow that sort of understanding to be built into the regional scenarios and find a way of sort of feeding that back up into the DFES scenarios. So that's what we're trying to do. So again, I think I would emphasize it's not intended to be top down. It's intended to be sort of both ways, or a two-way flow of information. There's a question from Amir. Would there be any coordination between DFES and FES frameworks? For example, FES has introduced new different access. Would DFES adapt any future changes in FES framework? I think that's a quick answer. That's yes. We're trying to keep the consistency of scenarios the same across FES and DFES. And so therefore the 4 scenarios, for example, in the DFES, we would expect to see in the DFES going forward, but that doesn't preclude the DFES, let's say, in a particular area, saying, well, yes, we need to produce a further scenario here because there is something that is more important locally that we need to bring out. So there's another question here from Matthew Page. Objective A, what is the capacity need across TD boundary? Won't be the same as embedded demand or generation. What figure for TD capacity is decided and how recorded as formal rights? No tech or TIC for DNO interface currently. Transition from grid code forecasting to formal upgrade requests, so specific capacity needed. I think that there's a lot of detail there, which I probably sort of can't go into here, other than to say I think the identifying network capacity needs, well, probably be better done when we go on to the next slide. Maybe do that, and you'll get a better sense of it. But it's trying to really work out consistency of how profiling is done, that sort of thing across network companies. So maybe come back to that after the next slide. Could we go to the next slide, please, Dan? Yeah. Okay. So this is what Jill and the team are currently working on, really as a standard report. So they're referring to it as a standard network capacity report. It's a straw man. On the left-hand side, you can start to see what the report is trying to do. So for the first 10 years, it might show a set of capacity requirements, which it does for every year, sort of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it'll base those on some sort of central forecaster scenario. And then for moving across, then maybe after the first 10 years, let's say 2030, 2035, 2040, right out to 2050, it'll produce some information for all of the DFES scenarios. It'll do that, and there's been a fair bit of discussion about, is this just really what does it consider? So it's looking at demand and generation capacity. So trying to identify network capacity issues both for generation and demand, and there will be a focus on both thermal loading and fault level. We're probably not going too much into the detail of voltage at this stage. So recognizing that it's probably going to be a fairly high level report focusing on thermal and fault level. And then in terms of coverage, focusing on bulk supply points and primary substations with some sort of tabular format used. So that's what the team is considering at the moment, and there's a report in draft which tries to capture all of that, and what the team will be discussing that in a bit more detail over the next few meetings over the next month or so before producing a report in October. So that's what the Product 5 team are doing at the moment. I should say the other aspect of this really is there is a lot of overlap with some of the work that BES and Ofgem are doing at the moment on the clean energy package, and some of you may be aware of the proposed network development plan. So I think there's a lot of overlap or synergy really here between what the standard network capacity report might be and what the network development plan report or requirement that is likely to be placed on network companies going forward will be. So we see, touch wood, potentially this report sort of filling that need going forward in a consistent way. So that's product 5. Can we move on to?
Before we do, John, there's a final question from Charlotte asking, is network capacity also to be broadly aligned for each scenario and specifically around the T and D interface? Do you want to pick that up?
Yes, I will try to. I think, again, that's probably one we need to think about a little bit more in the product team as part of the detail, and one to take back. But yes, certainly that idea of alignment is there, that idea of scenarios is there, and So I think the simple answer is yes, but I think, yeah, we probably need to do a bit more detail in exactly how that will look. Yeah.
Okay. Right, I shall pick up product 4, which is looking at data exchange in planning timescales. At the moment, the data exchange requirements between T and D are enshrined in the grid code, and they have been relatively unchanged for many years. And it's viewed that they don't really provide enough data exchange to allow us to develop an efficient network as we move into this brave new world of a smart, flexible network. So product 4 look at that data exchange and build on that to say what extra do we need to do to make sure that we can plan more efficiently with some of the major issues in front of both transmission and distribution companies going forward. So the 2020 work for this product is really building and carrying forward the work of the 2019 work. What they did in 2019 was to provide a report that said, well, this is the enhanced requirement for data exchange, both on distribution companies and on transmission companies. And reports were produced by the product and published in January of this year. I say reports. One of the reports was to detail the enhanced data exchange requirements. The other report was to look at how you would do that. It's fair to say that the enhanced planning data exchange is exchanging a significantly more amount of data than is currently done. Currently, the data is exchanged by exchange of Excel workbooks which contain all the data to provide models of the network. But the enhanced data exchange requirements would mean that this will be an extremely resource-intensive exercise. So the second report that was published in January looked at ways that we could do this data exchange in an electronic fashion. I think it recommended the use of the common information model to exchange the data as a set of models that represent certain demand and generation profiles. I'll come on to that in more detail on the next slide. But basically, those reports were done and dusted in January of this year. And the work of this year has been to get those proposals or recommendations enshrined into various codes. So I'm leading a grid code modification, GC 0139, which looks to introduce the enhanced requirement for data exchange, and is also considering how we would do that data exchange. So it's looking at how you would mandate an electronic data exchange, as well as the new enhanced level of data exchange. But there is a knock-on effect of that. Some of the data that DNOs need to provide to the national grid is not nowadays all in their own gift. A lot of it is held by third parties, whether they're IDNOs and the like, who have a lot of generation connected to their network, which is vital that we understand, both for the planning of the distribution network, but also planning the transmission system. So what we identified in last year's work was there was a need to strengthen the distribution code requirements to mandate an annual exchange of data, which will feed into the distribution network planning, but also into the grid code data exchange. So for that, I'm leading a working group on a distribution code modification. And you can see the long-winded title there of DCRP/MP/20/04. When you get these slides, you'll find that those are links that will take you to the website that will give you far more detail on those modification proposals that I intend to go through at this point. Are there any questions here at this point?
Sorry? Further questions?
P5 shows thermal and fault level capacity. What was the reasoning not also to show voltage limitations?
Yeah, so we're getting a bit of feedback somewhere, but I'll just pick that up. So it's a further question on P5. Yeah, as we're talking about the scope of that report, we stuck with thermal and fault level for the moment, recognizing that there'll be a huge volume really for DNOs with bulk supply points and primaries, and wanting, I suppose, to learn to walk before we can run. But it was felt that these are, thermal fault level are probably the key ones. It would be good to show voltage, but that might be some, I think that's probably a step too far at this stage, and it might be something that can get added in later. Really, I think is the answer to that.
Okay, Dan, if we can move over to the next slide, which is continuation and talking about product 4. This really just details the proposed enhancements to the data exchange requirements. So if we look at the left-hand box first, which details transmission to distribution data exchange. Presently, data is exchanged at week 42, where National Grid ESO provide DNOs with models or models, depending on which company it is, that represent a maximum demand, maximum fault level scenario. So what we're proposing going forward is that Grid will provide, probably at different points in the year, not just week 42. And you understand that this is ongoing work at the moment, but it's felt that to provide some of this data all in one go would, one, lead to data being out of date, but also would lead to a large amount of work for people all at one time and not spread the work throughout the year. So I think we're heading towards National Grid providing DNOs data throughout the year, and that would come as a single switch level model that represents the following scenarios of demand and generation dispatch. So we'd have a model that represents, and this is in addition to the maximum fault level scenario. We would have a model that represents the transmission system at the time of national peak, at the time of summer minimum, at the time of solar peak, GSP minimum demand, and then there would then be a further 2 models that would represent a high power flow north to south and a low power flow scenario on the transmission system. On the distribution system, or distribution to transmission data exchange on the right-hand side, at the moment we provide data at both week 42 and week 50, and that's both structural and system data presented in the form of a number of spreadsheets again. The proposal is really to align the system data requirements with the statement of works requirements. So that will include full details of the sub-transmission network and any connections directly to that sub-transmission network, whether those connections be to a DNO or an IDNO owned piece of network. So you can see here we're touching on again the requirement for IDNOs to provide detail where they have such large connections to a distribution network. It also includes details of any distributed energy resource connections that are bigger than 1 megawatt. So it's fairly basic details, but it's where it's connected, the size of that connection, and the type of energy fuel source that will that DER is, and that will align with the requirements of the recent Accuser change proposal 350, which requires distribution network companies, that means both DNOs and IDNOs, to publish all DER connection data above 1 megawatt. So there's an alignment here between the T to D exchange and also what has to be published in an open forum. There'll also be details of the DER connections that are greater than 1 megawatt and are accepted to be connected. So this is giving a little bit more of a forward view of what is likely to be the stresses on the transmission system caused by distributed generation and the like on the distribution system. We'll also be exchanging aggregated fuel type data for DER connections less than 1 megawatt. So what that will be is for in a typical distribution network where you've got grid supply points and then the next level down is bulk supply points, we will be providing the aggregated DER connected to that part of the network, but we'll disaggregate that by fuel type. And what we'll also be providing is the impact of all this, both the above and below 1 megawatt generation. We'll be providing the impact on system demand and fault flow, on system demand and fault flows of that connected DER. I think there's a question there. Is there a plan to publish distribution connected embedded capacity individually? Unit type. I'm assuming yes. There is currently a requirement to publish all embedded DER above 1 megawatt. That has been mandated by the introduction of the CUDA change proposal 350. I think it's fair to say that anything that we are looking to do in this with the D code modification and the grid code modifications, part of that work will be looking to see how we fulfill the requirements to publish data more openly and the best way to do that. So that might be publishing CIM models. That is open for debate at the moment. We're certainly looking to make all this data freely available, bearing in mind any confidentiality requirements. Graham's asked a question, aggregated less than 1 megawatt DER, will DNOs and IDNOs also provide to ESO accepted as well as connected for this category? At this stage, that hasn't been the intention. It's quite a fast moving picture for less than 1 megawatt. So what we do is provide that, as I say, we give an updated view when we have the statement of works process. So when we're applying for a statement of works for new corrected generation, we would update grid on the actual position for less than 1 megawatt. But at the moment, it's not anticipated that accepted ones will be published at that stage. Okay, that was all I had to say on product 4. If there's any more questions, drop them in. If not, I'll just plow straight on to look at product 1, which is looking at whole system investment planning. Essentially, this product is building on the work of primarily products 2 and 4, i.e. we're looking at whole system requirements based on the forecasting that we're doing for the demand and generation and using the enhanced data exchange that we're proposing from product 4. This product is looking at developing a process that will deliver the best whole system solution. And that would be looking at whether the best solution might be let's take, for example, a transmission system issue. The best solution might be a transmission network reinforcement solution. It could be a reinforcement to a DNO network, which would provide support to the transmission system. It could be transmission connected flexibility, or it could be DNO connected flexibility. So we're looking at processes that that will encourage the submission of different solutions, and also the way that those solutions are considered against each other in an equitable fashion. So we've been market testing some of the processes that we've developed, as you can see on the flow diagram on the left. We've been market testing those through a couple of projects that NGSO are developing at the moment. They're high volts pathfinder projects. One is in the Mersey region and one is in the Pennine region. National Grid have sought solutions from the transmission owner. It's sought solutions, it's saying the Pennine one, from both Electricity Northwest and from Northern Power Grid for the high volts problems in that area. And they're also going out to market to invite flexible solutions. And it could be that the solution is not just one of those different reinforcement or flexibility solutions. It could be a combination. So what we've been doing is developing a whole system CVA, which will allow us to identify which is the best whole system solution. And also we've been investigating and working with Ofgem to look at funding, the wider funding issues. It's quite clear how, if the solution is a transmission owner solution, how that's funded. Not quite so clear at the moment how, if it was a distribution solution, how that will be funded. And so we've been working with Ofgem to see how, what would be the way forward, and hopefully introducing new funding routes that will be applicable from the Rio ED2 period. Right, just I've noticed a question come up there from Matthew Page. Does this include whole system, most economic connection solutions for a given user, not just for wider reinforcement, i.e. user could connect to D, but it's cheaper overall to connect to T? We are looking, I'm trying to understand exactly what you're driving at with that question, but if the connection is cheaper overall to T, that is anticipated that will come out in, if any flexibility, if flexibility is looking to connect to either the T or D, then we would anticipate that the most economic solution would come by the flexibility provider understanding the connection costs to them of connecting to T or D, and that will be reflected in their costs. I hope that answers your question. If not, please come back to me on that one. Any further questions? If not, I will probably hand over now to John.
Yeah, let's move on to.
Yeah, okay.
Okay, so this is product 3, which is real-time data exchange and forecasting. So this picks up really short-term sort of real-time data transfers. It's looking at a number of different activities, such as the operational intertripping of distributed resources, how service conflicts are managed, how a connect and manage situation might operate. So that's where there might be sort of limited network capacity, and you're trying to make the best use of that. And also we're starting to do a bit of work into operational forecasting. So I've been supporting the team here that has been set up to do product 3. It will be, going forward, it'll be Ali Amidi from UKPN who will lead this area. So you can see along the bottom there's just a timeline of some of the things that, some of the outputs. So there was a fairly comprehensive report of the 2019 work, which was published back in January. And a month or so ago, we published a report into operational tripping schemes, which I'll come on to in the next slide. And then there's a bit more work towards the end of the year. So if we could move to the next slide, please. So just on operational tripping schemes. So what first of all, really, what operational tripping schemes are? They're about trying to help manage flows on the transmission networks primarily at the moment. So it's looking where there might be an overload following a system fault or outage condition, where if you can trip some generation, and that generation may be transmission connected or could be distribution connected, then you can manage down the overload. And what that lets you do is make better use of the transmission capacity and ultimately connect and operate more generation and demand. So this particular area has been sort of drawing on three operational tripping schemes, which have been developed by National Grid ESO and NGET, with the three DNOs that you can see there, WPD, SFCN, and UKPN, to help manage flows along and into the sort of south coast transmission system. So the report covers the sort of functional design of those operational tripping schemes, and it goes into the data exchange requirements at a reasonable level. It's those particular schemes at the moment, they're being developed. The UKPN scheme should, one that's been developed with National Grid, should go live around September, October of this year. So at some point over the next month or two, and the other two schemes will sort of follow in 2021. So you can see a bit of the sort of architecture there for the UKPN scheme. The schemes tend to be sort of built from the DNO side, built as extensions to the distribution management systems. In the case of WPD and UKPN, they're taking their power on systems and building extra functionality into those to enable the distributed resources to be managed back when needed. And in the case of SSEN, they're putting in place, they're building the operational tripping functionality into the Southwest Active Network Management Scheme that they're developing and installing at the moment. So there's a lot of how the distribution management systems work. There's then also the secure links, the so-called ICCP, or Inter-Control Center Protocol links from control center to control center, which are needed to exchange information as to what generation might be available to be tripped or reduced, and how much generation, let's say, the NGESO might want to call on at a particular time. So these three schemes are being developed and put in place. There will, across them, there should be about sort of 1,500 to 1,800 megawatts of DER, which will be available. So if we go to the next slide on this. Apologies, we're sort of running over a few minutes. This just sort of outlines some of the further work that we're doing in product 3. So the operational tripping scheme report, we'll update that again in November after we've got some experience of the UKPN scheme going live and some further development experience of the other 2 schemes. There is also work going on in the connect and manage and service conflict management space, which will primarily draw on the so-called regional development program that National Grid, ESO and UKPN are working on. And there's quite a lot of work that's already been done in that space, but at the moment, the focus is more on the commercial side and sort of working out the commercial framework for how the services would be used. And then the other area, which is sort of mentioned there on the slide, is operational forecasting work. So it's looking at how the ESO goes about doing its forecasting, and also how DNOs go about doing their forecasting, sort of looking at what sort of learning can be sort of exchanged between the different parties here, and obviously with a view to improving the quality of forecasts and allowing sort of better information to be exchanged, perhaps on embedded generation views, that sort of thing. So there is another area of work here which I'll just mention really, which is looking at data transfers really to improve network management under emergency conditions. So I think we're recognizing, and some of you may have seen an Ofgem call for evidence on DG visibility, which sort of follows the 9th of August event last year, and I think we're picking up on some aspects of that in this particular product as well, sort of starting to consider how information on supergrid transformer flows or frequency or distributed generation can be made more available really between T&D, so that those sort of emergency situations can be better managed. So with time in mind, I'll call it there, and maybe we'll go to the final slide and any sort of final questions. You want to pick this one up, Ian?
Yeah, I can, yeah. If there's any further questions, we've probably got, well, we're slightly over time, and if we've probably got 5 minutes if you want to submit them now. For further information on the Workstream 1B products, you can go click on that link there, and that will take you to all the products and all the reports that John and I have been discussing this morning. If you want to have more detailed information, you can contact the Open Networks at that address below. Okay,
thanks. I would also say, I mean, this is the first time we're doing this particular webinar really at because of some feedback that we got, I think, on one of the earlier PID consultations. I think it'd be good to know whether this sort of thing is a useful way of getting information across to people in an easy way. So any feedback you have on that would be really helpful. And indeed, whether there's any of the particular products maybe you would want us to think about doing a deeper dive into as well.
Yeah.
Do you have any final questions, Dan? Or is...
I can't see any come in. So unless there's anything else from you guys, just from me to say that we'll send the recording and the slides around to everyone that registered. So feel free to send them around to people you might think would be interested.
Right. I've got one more. I'm sort of promoting another bit of Open Networks work here. I think there were 1 or 2 questions there on getting visibility of distributed resources down to a megawatt and maybe below a megawatt. And one of the other products that we have in Workstream 2 is looking at, we're starting to do some work just looking at the value to stakeholders, to customers of maybe moving those embedded capacity registers below 1 megawatt. And I think it would be really helpful to us if we had input from stakeholders or views coming back to Open Networks about how that might be useful and where it might be useful. It would help us to form our thoughts on that, because it's an area that we haven't made any decisions on it yet. Okay.
Great. Thanks, John. And thanks everyone for dialing in. We'll send around the recording and the slides shortly. Thank you very much, everyone. Have a good morning.
Okay, thank you, everybody.
Yeah, thank you. Goodbye.